Guys, welcome back. We'll meet again. This time around, we'll be looking at uh, next chapter in the subject of instrumentation, SKMM3242. Now we are looking into transducer. Okay, let me open the slide. Okay, guys, this is lecture 8. We are looking at some introduction to the transducer. At this point, basically, we know that for the whole syllabus, we are now entering from section 2 to section 3 of our, content. I want to recap again. Section 1 basically tells us more about the theory, about the operational characteristics of the instrumentation system, the basic of instrumentation system, data analysis, analog to digital, very basic instrumentation system design, then going down to the zeroth order, first order, and second order instrumentation system. Okay, from there we move on to the section 2 of the whole syllabus, which is the signal conditioning. We are looking at the op-amps, filters, and rectifier bridge, Wheatstone bridge, sorry. And then now we are moving into the third section, starting from the transducer, some introduction on the transducer, and then we will be following through discussing about each and every transducer in detail. All right, construction, the theory behind it, and how do we use all these transducers. All right. So so this diagram, this slide shows a very typical system of instrumentation. You have to basically be familiar with this block diagram. You have 4 components there. You have the transducer, signal conditioner, analog to digital, and display. We have seen this thing from section 1, from the first section of our syllabus, of our lectures. By now, I think you should be able to understand what's behind all these boxes. All right. So what is a transducer? Transducer is basically an electromechanical device that converts mechanical change into this definition actually is good for sensor. All right, there's something wrong in this slide. Transducer basically, a device that reads some information from different form values and convert to to a different form. Okay, it can be any form, but a transducer basically, the job is to convert readings from one value and putting out a reading in a different value. For example, mechanical to electrical or electrical to mechanical. So the job of a transducer is basically just to change. All right. So transducer is basically divided into 2. You have sensor and actuators. All right. When you speak about transducer, you have to put in mind that you are talking about 2 things, which is the sensor and the actuators. Okay. So the sensor is basically, the job is to detect any changes in physical parameter, for example, speed, pressure, temperature, humidity, and many others, and convert those information to some kind of electrical output. All right, that's the job of a sensor. And then for the actuator, basically they receive electrical impulses or input, and then they convert the electrical signal or impulses into a form of physical output. Okay, for example, we go back to the sensor here. If the sensor is sensing vibration, okay, so the physical parameter will be vibrating object, okay, object that vibrates. For example, a speeding car, so you can see the car is basically vibrating at a high speed. Then when you have sensor, basically the sensor will basically sense the vibrating elements and convert those vibrating elements to electrical information. Okay, so this is the information that we get from a sensor. But then when we move forward to the actuators, actuators basically receive electrical information signal, voltage and current. They convert that into a physical or a mechanical movement, for example, here motors, okay. For the electric motors, you are sending electrical signal to the motor from battery, from your controllers, and then you will observe that the motor is rotating. All right, so electrical to physical output. Electrical here in this case is the speed information that we give to the motors in the form of current and voltage, and the physical output that you can observe from the motors is rotation. Okay, so it can be, you know, any kind of physical output. Rotation is one thing. You can have linear motion, you can have non-linear motion, you can have you know, valve opening and close, for example. Okay, so that's it. Is the very basic definition of transducers. Okay, also this slide we have seen the definition just now. I will not go through to the detail of each and every one of this one because I have explained this. There are two types of transducer. You have input transducer, you have output transducer. Okay, which is this one is basically referring to the sensor and actuator. Okay. Okay, for the classification of transducer, you have analog and digital, of course. Analog transducer, for example, here voltmeter and oscilloscope. Okay. You have digital transducer, for example, here encoder. Okay. For the analog transducer, you can see voltmeter when you put the probe on the things that you want to measure. Basically, you will be observing the needle of the voltmeter, or you know, the signal in the oscilloscope moving. So those are basically analog kind of information. Okay, hold on. Okay, and then for the digital one, basically you will have the output, or your observation is in digital form, which the value is either 0 or 1. Here you see is either high, low, or on and off. For the voltmeter or for the analog transducer, the voltage and the current is basically changing from 0 to any maximum operating voltage, for example 5 volt or 12 volt. So the information in this analog transducer basically varies and change between this range. Those are for analog transducer. For the digital transducer, the value is either 0 or 1. Okay. So this is the example of analog voltmeter. You are seeing the needle over there. Okay, the same thing goes here, oscilloscopes. Okay, next we will be looking at the passive and active transducer. Okay. For the passive transducer, actually this is some kind of transducer that does not need any outside power supply in order to operate, for example RTD. So in this case RTD, you know, without the presence of power supply, for example battery, you can basically observe reading from the, if you put a multimeter probe to the RTD, you will have some reading without the RTD connected to any circuit, without the RTD connected to any battery or any kind of power supply system. Okay, these are the passive transducer, meaning that without the presence of power, this sensor can operate. Okay, if you put the sensor in the box or in a plastic bag or something, it is basically taking and giving a reading, basically, right? So in contrast to the active transducer, they need battery, they need power supply to work. Without the power supply or without batteries, basically this sensor is just like a piece of metal, you know, it's very much unuseful. For example, here is the LVDT, right? This is the RTD. Okay, all right. So later on, we'll be looking at all of this transducer in detail. Basically, you have capacitive, inductive, resistive, piezoelectric, thermoelectric, photoelectric, piezoresistive, pyroelectric. You may have strain gauge at the end. All right. So This is very much the end of lecture on the introduction to the transducer. I'll see you again in the next lecture. Goodbye.